Hello. This is the last day of class, thank God. The last day of COVID-19 class for spring of 2020. Let me go post this meeting real quick just to make sure that everybody officially can see it. Okay, you guys made it. Hopefully everybody made it. I don't know if everybody made it. I didn't check to see if anybody dropped out, but I know a couple of you had to. Excuse me. So guess what, guys? For those of you that are here already, I was up till about 4:30, 5 o'clock this morning, dealing with an issue that I should have not had to deal with, dealing with a physical security issue that I had outsourced, yet I had to deal with it. So we'll talk about it for a minute here. Let's wait for some other people to come online. Oh man, I need to get some coffee or something. If you've got questions about like when the exam is going to be ready and when I'm going to start grading stuff, that's all going to get done here in the next few days. But again, I'm being very lenient on grading. Being going to be very lenient on exam 3. Should be pretty easy. Exam 2 is going to have a pretty healthy curve on it. Yes, 4477 Zoom meeting. Last Zoom of the spring. This is the last Zoom of the spring, thank God. Anybody in here, anybody right now taking summer school? Any of you guys taking summer school?
Nope.
We have to do all of them online like this. I mean, there's pros and cons to it, but it's been more difficult for me, mostly because of COVID-19 and what else I do. Okay, one sec, just need to share this. Send a copy, submit. All right, so maybe we'll only have 3 people for the class. That's okay. Well, a lot of people in the class were expecting to see these online. I posted some of them. I got to get them all, the rest of them posted. I'm not very good at editing videos and also had to reinstall Zoom. So let me tell you guys what happened. So I've mentioned that term co-location before. Let me share my screen too so I can see what's going on. Make sure this computer stays cool. Oh, technical blowing on the computer there. So the data center where I house most of my servers for my business. It's not my data center, I rent it from facilities management, a facilities company. They provide the electricity and the air conditioning and the physical security and the location. I pay rent, basically. It's like renting an apartment for your computer. It's called IP Global. And I'm not showing you this to get them in trouble or anything. That's not actually their building there. It's a bigger building than that. I'll show you what the building actually looks like if you're curious. That's the building right there. Oh, that's so funny. And that's my truck right there. No, that's not my truck. It looked like it for a second. So that happens to be a data center. It's not a very big data center, but it's a local data center. Notice what's interesting about this data center. There's no windows in it. There's a whole bunch of air conditioners there. There's a big Cell tower. It's one of the biggest cell towers in Houston right there, guys. You guys can see my screen okay, I hope?
Yes.
Okay, good. So nobody these days, small to large companies, nobody these days is running their own data centers anymore because it's expensive to do that, especially if you're not in business to run a data center. We're outsourcing everything either into data centers or co-location facilities like this, or we are using something like Microsoft Azure web services, and we're doing like software as a service. So that's what I use. I use this data center here for all my servers. I would happen to be there last night because I was doing some things that needed to be done late at night that required rebooting some of the servers, and I noticed that the data center room itself was getting warm, like more than 70 degrees, which is unusual. So I walk in there and I see that one of the two air conditioning systems, you always have two. It's like having two cars in the driveway. This is a critical need. So if you needed to mitigate against an outage of not having a car, you'd buy two identical cars and you drive one day and one the next day. That's how you keep a backup. One's not really a backup. You just alternate them. But that's how it is in most data centers. Got two air conditioning systems. They use these big Liebert air handlers. Liebert data center air handlers, which not critical for you to know what one of these looks like, but this is essentially what they look like. These are air conditioners. There's one not installed. It's just sitting on a rack. Or sitting on a pallet, I should say. That's what these things look like. There's two of them. Always, at least two in every data center. That's okay. Just finishing the TP exam, no problem. And I'm recording this too, guys. So one of those is running at a time. Well, it had an error on it, head pressure or whatever. The second unit that was in there was on, but it was not operating. It was not putting out cold air. It hadn't cut over yet. So I said, okay, no problem. At some point it'll cut over. So temperature got to 80 degrees, didn't cut over. 85 degrees, didn't cut over. 88 degrees. Now I'm starting to panic because the nominal operating range for servers is 90 degrees is the maximum. Yeah, they'll probably work for a little while above 90, but 90 is kind of hot. You guys can work for a little while at 90 degrees, but eventually you get hot and when go inside, you get some drinks. So they don't like to run at high temperatures. So I made a call, and this is like 2 in the morning. I didn't plan to be there that long. It was about 1:30 actually. And made some emergency phone calls. Finally, somebody showed up. Didn't take too long because they knew there was a problem. And we troubleshot the problem. I helped them troubleshoot it, and we got the second system running. But for some reason, something broke down. Some watchdog, and that's one of the terms that we'll learn today, by the way, some watchdog program. There's some automated system which was supposed to be watching those two air handlers, was not doing its job. The watchdog was asleep. So in the networking world, a watchdog basically is an automated program or an automated system that watches other critical systems for us 24 hours a day, or they watch it for us so that we as humans don't have to watch them. Why do we have a watchdog? Because they're cheaper than humans. Why do we have a monitoring system? Because it's cheaper than a watchdog, and a watchdog can't probably tell us, hey, air conditioner's broken. So it malfunctioned. My customers, I had to tell one of my customers this because they were a hospital, and I potentially had to turn off their servers for a little while. Well, hospitals are operating 24/7. They were not happy about that. I thought I was going to lose a client, but so I talked to them. So we got it back up and running, and it got cool pretty quick. But that's an example of a threat. The threat is an environmental threat that I was trying to mitigate by not having my servers in a data center that I personally own and manage because I probably can't afford 2 air conditioners. Put them in a data center, and they kind of fell down on the job. So I hope they fix that issue, because it's not just me. There's dozens of other clients in there, like Mattress Mac and Gilman Honda, and a lot of local mom and pop shops. There's a lot of organizations that have servers and data in those racks and racks of servers at IP Global. So very disappointed that that happened. Inside, by the way, let me see if I can find a picture of what it looks like inside IP Global. They've taken a lot of their pictures offline because a lot of times we don't want to show you what's inside a data center. That might be an example of what it looks like inside a data center. You have a hot side and a cold side. That's the cold side. See the little holes in the floor? That's where the air conditioning's coming up through the floor, going into these perforated racks. Hot side is in the back. That might be an air conditioner in the back. Did I type in IP Global? Oh, no, I typed in IO Global. No wonder it wasn't coming up. Yeah, that's an example of one of the hallways in IP Global Networks. And I'm usually laying on the floor with a laptop, or I have a pull-out rack there that I pull out and mess with. But a lot of times I'm laying on the floor because it's nice and cool on the floor. So anyway, chapter 12, we're on chapter 12, which is the network management function. Where is my content? Let me download this PowerPoint real quick. Let's get into it. Let's see if we can get done. I may be able to get done. I may need to have a bonus class just to talk about a few more things, but I think we can get through it today. In terms of network management, by the way, before this fires up, what do you think is the most expensive element in a network? Is it the servers? Is it the circuits? Is it the data? What is the most expensive element in a network environment? What is the most costly? What either costs the most to have or costs the most to deal with when it causes a problem? Nope. People. Whenever I ask a question like that, what is the biggest issue with networks? It's people. What's the biggest problem with our planet? Is people. And for a lot of reasons, but because we're not machines. We need time off. We need vacation. We feel sad sometimes. We need sleep sometimes. So people. Also, at some point, computers used to be much more expensive than people, but now computers are cheap and people are expensive. Servers, Eric, I can go buy used servers for $100. Super cheap. They're 5, 6, 7-year-old servers because Google or whoever's constantly upgrading, updating. So people are cheap. Excuse me, people are not cheap. People are expensive. And computers or hardware is cheap. Keep that in mind for network, in terms of network management. Okay, there's several new terms you're going to be introduced to. Maybe you know some of these, maybe you don't, so I'll try to point these out. What do network managers do? What do I do all day other than teach? Well, I sit around and drink a lot of Monster drinks and stay up 24 hours a day and play Fortnite. No, that's not true. That's what like the techie guys do, but MIS managers don't do that. Network management, the generic description, generic definition of network management is the process of operating, monitoring, and controlling the network to ensure it works as intended and provides value to its users. And this also includes performance management and upgrading a network, making things better as well. Although that kind of falls back into network design, but making sure a network is being used right and it's performing optimally. What do network managers do? Well, we perform operational tasks. We manage the day-to-day operations of a network. We provide support to network users, which might be customers, might be employees, might be students. We ensure the network is operating reliably and not giving out bad information or not up and down and not intermittent. We evaluate and acquire network hardware, software, and services. We manage a network technical staff. Many times network managers have a staff of technical people with computer science degrees or IT degrees working for them. So we have to have some skill in management as well, or people management as well as computer management. And we also manage a network budget with the emphasis on controlling costs. Network managers, MIS managers for most companies, are some of the highest paid employees that deal with some of the largest budgets for most companies. Strategically, network managers attempt to develop long-term networking and voice communication plans to meet the organization's policies and goals. So we always need to be forward thinking. Excuse me. Network managers need to be paying attention to trends in the market. You need to be going to conferences and maintaining your education of what's new in the market, not just new hardware, but new applications, new procedures, new methodologies, new way of doing things. Need to keep abreast of the latest technological developments in computers, network software, telephone technologies, and the internet. You also are responsible for assisting senior management in understanding why are we spending so much money on doing a certain thing? Why are we spending so much money co-locating into a data center? Why are we switching to Azure networks, for example? Why are we spending so much time automating things and so much money automating things? Why don't we just hire more people? There are reasons for that. A managed network. A managed network is any network that's managed by devices themselves with the aid of a network manager. Network managers don't typically manage by rule. In other words, we don't log into all the servers and all the hardware and run reports on every single thing. There's just too much for us to look at. Most network managers are dealing with several network systems. We've got a data network system, we've got a camera system, we've got a phone system, we have a air conditioning system, we have an electrical system, a physical door access system. We got all kinds of networks and systems to deal with. So the more that we can get automation on that job, the more that we can automate, the more smart devices that we can buy. And I'm not talking about, when I say smart devices, I'm not talking about smart lights and things that you can turn off and on from your cell phone. I'm talking about devices that can manage themselves and report to you when there are issues so that you as a network manager can manage by exception. Exception. You guys ever heard that term in any of your management classes? Manage by exception. That is, you pay attention to the stuff that sticks up. You pay attention to the nails that are popping out of the wood. You pay attention to the squeaky wheel. You grease the squeaky wheel because it's squeaking. All the other wheels are nice and well greased, so they're not squeaking, they're not causing problems. Network managers, we can't spend a lot of our time in day-to-day operations looking at an entire network function. Even with small organizations, I don't have a big network set up, but it would take me forever just to log in the morning to all the different servers that I provide to all of my clients. It'd be 11 o'clock by the time I could get my first cup of coffee. Managed devices, more expensive, I'm talking about switches, routers, gateways, the interconnecting devices, applications that you can use to manage those devices. Cost a little bit more money up front, and they do take up bandwidth. A managed network uses a little bit of that bandwidth to report messages back and forth so that devices communicate with each other. But what we're trying to keep is costs down by keeping people like me, network managers, from having to get up from my desk and go walk somewhere and see, is this system on or running? Managed devices can report when issues arise. They can also, the smarter ones can look at trends and tell you, hey, I'm noticing that I'm getting a few more errors on these hard drives that I'm supposed to get, or the temperature's creeping up slowly over the past few weeks in this data center. Maybe there's a problem with the air conditioner. Maybe you need to go check that. Device management software, we also call it point management software. This allows managers to monitor performance and configuration of the devices on the network. Then you also have systems management software, which we can use, and usually this is very expensive software that manages an entire system, a process, for example. And then you have application management software that's just looking at applications. Systems are looking at servers. Applications are looking at applications. Devices management software is looking at the interconnecting devices themselves, the physical management. So this is basically physical layer, network layer, application layer. 3 different types of software that live in these 3 areas. The most expensive thing to do, by the way, is application management. The most commonly done thing is physical management, because this is where most problems start. In the physical world, that's where most problems start. Ignore that chart. SNMP, we do this. These devices talk to each other, and since many devices are made by many different manufacturers, a common protocol was developed years ago called SNMP. Stands for Simple Network Management Protocol. Any device that speaks SNMP can be turned on and set up so that it either dynamically spits out data, like we're talking about throughput, bits per second, frames per second, temperature, all kinds of different variables that you can monitor on hardware or even on databases as well. But it's predominantly for hardware. That data is stored, can be stored in a database not on the device, because most devices don't have enough storage. The transactional data is stored in what's called a management information base. The best example of an application that uses SNMP data that I can think of is MRTG. It's an open source program that many network managers use to manage and manage switches, manage routers. It stands for Multi-Router Traffic Grapher. It provides us a nice graphical interface. This can be in hours. Usually these are 15-minute increments. The green line or the green waves represent, in this case, inbound traffic, and the blue line represents outbound traffic. Or maybe that's vice versa, but I'm pretty sure that in terms of most people's networks, inbound is about 80% higher than outbound traffic. So we as network managers look at this. We also use automated tools, but we look at this because we're looking for trends. We're looking to see where our usage goes up. We're looking for spikes to see if we're getting spikes on our network. Sometimes spikes are okay. Sometimes we expect spikes. You're going to get network spikes at certain times of the day, like at midnight, for example. You'll get data spikes because you're doing offsite backups probably. Sometimes you'll get dips. If you see a dip that goes down to 0 and goes back up, well, that probably indicated that this device, whatever it was, it rebooted right there. Or something happened to it and it went down for a few minutes. That's from 2000 hours to 2200 hours. That's about a 15-minute interval right there. Something happened right there. Something needs to be looked at there. And there's lots of versions of that. Excuse me. Yeah. Again, this is going to be tough for me to make it. I'm going to try. These devices are all talking to each other and talking to you. You can optionally log into them, but most of the time they're talking to each other and they're sharing their data to a database. And then we as a network manager log into the database, not to the device, but to the database, and we look at those graphs. I used to use MRTG a lot. I don't do it so much anymore, but at U of H, the network managers definitely are using MRTG. It's oftentimes running on a monitor on the wall because it helps us recognize trends. You can see examples of it, by the way. If you open up, like for example, in a Windows computer, you can start your task manager up and you can see an example of what one might look like under performance and networking. You can see something that looks kind of like network. Now, I don't really have much going on. I do have a little bit going on here. I don't see too much going on. And look at processes. All right, let's look back at performance. CPU usage. That's another one that memory usage. Anything that's graphing. This is a visual aid that helps network managers recognize that there's problems or trends. We're looking at historical data. Okay, again, in network management, here's some other things that we do. Load balancing. Make sure you know what that term load balancing is. We use load balancing when we know that maybe there's a server and we're using MRTG, or maybe there's a switch and we're using MRTG and we recognize that, hey, it's pegged at 100% all the time. Well, maybe we've got too many requests from the internet coming into that switch, so let's spread out our network. Let's create a hierarchy. Let's put a little high-speed switch, not little, let's put a high-speed device in place, which simply is receiving these web requests and farming them off to what's called a farm. That's why I call it a server farm. You have a special device called a load balancer, which farms off the requests to multiple servers, all of which have identical data on them in this example. This might be an Amazon.com, for example. And it is showing you who is Galaxy S7 Edge, by the way. Is that me that accidentally logged in? Or is that somebody else? So this is an example of Amazon.com. There obviously needs to be more than one physical server in the world for Amazon.com because there's thousands of people using it per minute. One server couldn't possibly handle 1,000 people per minute accessing, or 10,000 people per minute, whatever it is. So we use load balancing. Here's some other terms that you will encounter, which go hand in hand with MRTG and managing throughput or managing bandwidth. Make sure you understand what that term means, bandwidth. What does bandwidth mean, guys? What does it mean, Esmeralda? Do you know bandwidth?
I hear it all the time, but I think it's like, isn't it like capacity? Kind of?
Yeah, it's your capacity. It's the total number of lanes you have on your freeway that connects your network to the rest of the world, or your network to other nodes on your network, your bandwidth. For WAN connections and internet connections, it's whatever you're purchasing, your 100 megabit, 300 megabit, gigabit, whatever it is, that's your bandwidth. You may be using 1%, 10%, or 100% of your bandwidth. We don't want to always be using 100% of our bandwidth. That's a traffic jam if we have that issue. So bandwidth, total number of lanes on our freeway, or the width of our freeway, or how fast we can drive on that freeway. Sometimes we want to limit the traffic on a freeway and give some traffic priority, such as emergency traffic, for example. In the real world, we give emergency traffic priority, or we give specialized traffic that's been tagged, like when it's an easy tag. They get their own special lane. Some easy tag lanes in some states, the speed limit is actually faster on the toll roads and on the HOV lanes. I don't think that's true here in Texas, but it's certainly true in Kansas and some other areas where you can drive as fast as 85 miles an hour on some toll roads. So traffic shaping and traffic limiting are two concepts that we use on, let me wipe all that away, two concepts that we use to control network traffic. We can do it a few different ways. We can control it based on quality of service markers or flags. In other words, what kind of data is contained within this packet, this IP packet? Is it a voice packet? Is it an email packet? Is it a streaming video packet? We treat voice and video packets with higher priority because streaming data needs to have a relatively even stream, a minimum number of frames per second, so that we can view it as video and it doesn't sound choppy. Whereas it doesn't really matter with email or static photos how fast those download, as long as we eventually see them. So we can shape traffic based on priority. We can do it based on traffic type. We can do it based on port number on a switch. Like if there's data coming into and going out of ports 1 through 5, we can designate that as a very important range of port numbers and say, well, those are servers on those ports. They need the highest priorities. And ports 6 through 24 on this switch are workstation ports, where there's only one machine behind those ports, so you can lower the priority on that data. You can limit bandwidth in the same way. You can limit it based on port number, not just prioritize it, but literally give only a certain minimum or maximum amount of bandwidth based on what the protocol is. For example, you can actually limit, a lot of companies have issues with employees wasting their bandwidth or using up all their bandwidth because they're watching Netflix. We can ban Netflix, but what a lot of network managers do is we know it's easy to get around Netflix with different methodologies. We limit the bandwidth so you can still view videos, but there's maybe a total aggregate maximum bandwidth of 10 megabit per second for all of Netflix traffic from Netflix.com, so that if we have a 20 megabit per second connection, we're using no more than 10 for Netflix, and that gives us another 10 left over for everything else. We're cutting off the tops of those peaks with traffic limiting and traffic shaping. That's why it's called traffic shaping, cutting off the peaks. We don't want peaks in our networks. We want our network traffic to look pretty even, pretty smooth across the board. We don't want it to be near the top. We don't want it to be near the bottom. We want it to be somewhere near the middle and nice and even. QoS, make sure you know that term, quality of service. And we type it with a big Q, a big S, and a little O, quality of service. Tagged packets or frames. The content type, I should say, not the actual content, but the content type. Content caching. Everybody in here should know what content caching is because you deal with it all the time. A lot of data that we download off the internet is static data. A lot of it's not dynamic. Like if you go to uh.edu, for example, or let's choose a better one. Let's go to espn.com. Some of this data is dynamic. In fact, a lot of the data is dynamic, but a lot of it is static data. Now, did you notice how long it took? I don't even have ESPN.com up yet. It's taking a long time, isn't it? You know why it's taking a long time? Because I don't visit ESPN.com that often. I'm not a big sports fan. But I will tell you, there's a lot of stuff on this page that doesn't change much. The text changes, but this logo doesn't ever change. This streaming advertisement, there's only a few of those. That button doesn't change. The stuff at the bottom doesn't change. The menu bar doesn't change. These things are static. Now watch what happens when I reload ESPN. It's going to pop up a lot faster. Why did it pop up faster? Because all these static pictures and buttons and advertisement and all that junk is already downloaded to my local computer and sitting on my hard drive. There's a copy on my hard drive. That's called content caching, or just caching in general. What we're trying to do is limit the use of the bandwidth. So anything that's static, and this is what, by the way, the Wireshark assignment was trying to show you guys how to do, how to figure out what was caching and what was static data and what was dynamic data. Content caching, very helpful to keep traffic. What we want to do is we want to keep traffic off our networks, especially if it's static traffic. Movies, for example. Anybody watching The Mandalorian in here or watching any movies on Netflix? The movies themselves, those are streaming, and it may be the first time you're watching it, so it's probably not cached on your local hard drive. But when you go to Netflix.com, Amazon.com, or Disney.com to stream The Mandalorian or whatever it is you're watching on TV, I'm watching The Community right now. It's a fun sitcom. I'm watching a copy of it, you know, because this series or this movie was made months ago or years ago. I'm watching a copy of it. I'm watching a local copy of it that probably exists on a server in Dallas or maybe even Houston, and that's because it's physically closer to me. Somebody in San Francisco is watching a version that's on a server that's physically closer to them, but it's just a copy. It's a static copy. Content caching. The goal of caching is to keep the static data close to you, close to the recipient, as close as your local hard drive sometimes, or as close as your local city. I'm losing my voice. Continue. There are content delivery networks. Some of you've probably never heard of these. Akamai. Probably never heard of Akamai or Level 3 or Sesquinet. These are content delivery networks that basically their job is to duplicate data, static data, movies, distribution, software distribution, historical trending data that you can purchase, historical finance data. They copy it and they store it in 20 or 30 or 40 major locations all over the globe, so that depending on where you are physically, you might be getting the data off of a mirror. We call them mirrors for content data. That's closest to you, a local mirror. Like when you're downloading Linux, for example, the Linux operating system, which is the thing I love to use, you're usually downloading, if you go to CentOS.org, say, I want to download this CentOS and install it on an old laptop and see what Linux is all about. Chances are you're going to be downloading that from a server in Dallas or even Houston or Texas A&M, whereas somebody somewhere else is going to be downloading it from Switzerland or China or wherever they happen to be physically closer to. That's the same concept as content caching. Configuration management. This is another thing that network managers do. We configure networks and client computers. One of the most common functions that we use to perform is adding and deleting user accounts. These days, that's usually automated. When you guys become a student at University of Houston, you have a student ID, but you don't have a user account until you take it upon yourself to go log in to the access.uh.edu and you apply for an online account and you set your own password and you enter that critical data. And that's because the concept of adding and deleting users, that's very time intensive and personal intensive. And it's not a good spend of your money to have network managers or help desk people doing that for you, or changing your password, for example. It used to be if you forgot your password, you could call up a person at U of H, they'd reset the password for you. These days, if you forget your password, what do? You answer a few questions or jump through a few automated hoops to reset your password. Only as a last resort do you have to talk to a person, which is okay because password recovery is very generic. It's also very common. Everybody forgets a password at one point or another in your life. One thing that network managers are bad about doing, because we forget to do this, is deleting user accounts. That's all automated now too. So when you leave the university and you graduate and you get your great job making $85,000 a year, whatever it is, eventually your student account will be deleted. Now, when I went to U of H back in the mid to late 80s, when I graduated, my student account was there when I came back to school in 1988. And then when I finished in 1992 and came back to teach in 1995, it was still there. That's why I'm Jake at uh.edu, because we were not being good about getting rid of those user accounts. That's super important. Get rid of old user accounts because one, it takes up extra space on your network, in your database. Two, you're giving users, it's like not getting the keys back from somebody after they've rented an apartment. Please return your keys. Well, if you don't return your keys, they fine you and then they change the locks because they don't want you to come back 6 months later to try to get in that same apartment. And then desktop management, it's another thing that we do. Help manage the desktop environment for the user, upgrading software, helping to provide help desk services. Documenting the configuration. Again, that's 50% of what you guys are going to be doing is documenting. 50% of the time, documenting and updating documents. Can you press your, who was talking just then? Press your mute if you're going to make some more noise. So that's why I have you guys do the draw.io diagram, by the way. I'm going to show you this, by the way. If you're not clear on what to do for the draw.io assignment, take that slide right there, figure 12.7, and simply duplicate that in draw.io. Customize it to some degree that's a little bit different. Use different colored lines for different circuits, fiber circuits versus copper circuits. This is an example of a backbone network. Here's the access layer backbone. Here's the core layer backbone, distribution layer backbone. Not a LAN, this is a backbone. You can choose to draw this. I would prefer that you draw this and customize it a little bit. And then there is a draw.io extra credit where you take the same drawing, save it as a new drawing, and get more detailed on it. Maybe add another layer where this switch up here is connected to a LAN, and you connect it to another draw.io drawing over here, and this is showing workstations and printers and cameras or phones. Add to it. Make it so that when I hover over something, it gives me additional information about that item, like what its IP address is and password, and what applications are running on that server, what how do I access it? That kind of stuff. Give me some meaningful data on there. Okay, so hopefully that'll help you guys with your draw.io assignment, which is due by the end of day today. If you need more than a couple of days to do it, that's fine, but try to get at least the first one done today if you haven't already done it. NOC, Network Operations Center. This is what some of you might be doing, managing a network operations center. These are typically employees that are not dealing with end users. They are managing from a centralized location the day-to-day operations of the network. They are many times managing operations of multiple systems and multiple networks. In this case, you can see he's got MRTG running in a couple places. He's got video cameras running here. Many times in network operations centers or NOCs, we have one of these monitors is going to be showing CNN or Fox News, because if you're a global company, you need to keep up with what's going on globally in the world, like what's going on with Kim Jong-un in North Korea, or what's going on in Asia, or the Chinese market's having a problem, or there, you know, did Bill Gates do something in California? It's maybe you haven't heard of it now, but these could have significant effects on what a network operations manager chooses to do and how they manage their network. We usually don't deal with end users. Network operations people many times are not good with people. A lot of them they have Asperger's, or they're weird, or they're alternative people, if you know what I mean. You know, the guys that drink the Monster drinks and have, you know, gauges in their ears and things like that. When I used to hire network operations managers, that's kind of what I got a lot. And that's a lot of times these are guys that work at night from 11 at night till 7 in the morning. They don't like dealing with humans, but they're really good at dealing with computers and programs and really good at noticing, hey, there's a little spike in that graph here. Maybe there's a problem. The help desk, as opposed to the network operations center, is the first line of defense, and a help desk is what end users typically are communicating with. They have a different set of skills. Help desk people are typically lower in, they know less technically, and they know more socially. They are better at dealing with humans and the issues that humans have when they're using an asset, a network asset, and something's wrong with it. Either it's broken, or it's not available, or you can't connect to a particular application or a database. Many times they're trained from scripts. And I know all of you that I'm talking to right now have probably dealt with a help desk person before, either at Xfinity or Verizon or AT&T, or you've called one. Most help desks, by the way, are outsourced. Make sure you know what that term means. I'm sure you already know what that means. Why are most help desks outsourced and not run by companies as opposed to the network operations center? And that's because that's kind of a specialized social set of skills where it's cheaper to find a company that has pre-trained people to ask the same questions and deal with the same insecurities that end users have with respect to their network function. Also, we can outsource them to countries where the FTE, the full-time equivalent cost per hour, is less than $5 an hour. Excuse me, not greater, less than $5 an hour, like the Philippines or Indonesia or Honduras or India. Although India is getting a little bit more expensive and getting a little bit better, they can demand more money. That's why most data centers are outsourced. Anybody in here? Esmeralda? Ramiro, you ever dealt with an outsourced help desk?
I haven't. I don't know if I would know if I.
Maybe you might not know. Maybe you have and you didn't know that. They are getting better. It used to be really obvious because it was usually a heavy Indian accent, because that's where most outsourcing centers started, was India. These days, a lot of them are in the Philippines. You're not Filipino by any chance, are you? A lot of them are in the Philippines because English is a predominantly spoken language there. They have pretty good accents. They have a lot of people in the Philippines, and they're relatively well educated. Honduras, another place. Where else? Those are like the couple that come to mind right now. Most help desks are running software which help them manage the social interaction of a person with a problem. Ticket numbers are assigned so that we can keep track of these problems, and so that you as the person calling with the problem can refer to that ticket number if you want to add more information. Keep your ticket open, and because the issue is not resolved, we're looking for resolution. Priorities are assigned to these trouble ticket systems based on the impact, what the issue is, based on the impact of the problem to the remainder of the network. If you get one person calling, saying, hey, I can't run this application, it's not running well. Well, maybe that computer just needs more memory. But if you're only getting like one call a day for that, it probably is not a system-wide issue or problem. You get calls where 50 people are calling you in the last 10 minutes and saying, hey, our internet access is down. Well, maybe there's a global problem. Maybe it's a global pandemic. There was a global problem that needs to be escalated. That's a term, by the way, when there are multiple reports of same issue. And most help desk software helps us quantify or enumerate these issues into like the 10 most common issues. And we might say 1 equals internet down, and 2 equals, can't access data, something like that. If 50 people call in the last 10 minutes and say their internet service is down, that means there might be a WAN problem upstream that we need to look at. And so that problem gets escalated to the NOC. And the network operations manager takes a look at it. Now, chances are, and if it's a good network operations center, they already know about it. If they're being pre-active or proactive, they're already knowing it because of automated systems. Not always. But a network operations manager does not want to hear from a help desk saying, hey, 50 people just reported that the internet's down without them already knowing about it. The help desk, the goal of most help desks is to provide the support. It's an 80-20 rule. 80-20 rule. The help desk is there to provide support to 80% of the users and deal with 8% of the problems, and 20% of the problems need to be escalated to the network operations center. The 80% most common problems. We just follow the 80-20 rule. If there are certain problems that we're noticing are occurring more and more often that are falling into that 20% bracket, like our internet's going really slow, well, we might want to figure out what we need to do to mitigate that and then put that into the 80%. Maybe it's not that the internet's slow, maybe it's that it's training the end users are, maybe they're using Netflix and they're not supposed to, and that's slowing the network down. So it might fall into the 80% by the help desk saying, well, you're not supposed to be using Netflix, or that's a violation of our acceptable use policy, for example. How are we doing on time? We're good still. Okay, performance management. Performance management. Statistically, the term availability refers to the uptime. How available is a network or a system or a database or a network connection? Availability. We are striving for the gold standard for network availability is called the 5 nines. Ever heard that term before, Esmeralda, the 5 nines?
Sorry, it's like it's cutting off a bit. Can you repeat the question?
The gold standard for network performance and availability is called the 5 nines. In other words, we want our networks to be available 99.999% of the time to our end user. That equates to about a downtime total of less than 30 minutes per year total in aggregate. That's a pretty secure network. In other words, it's pretty available. It's a pretty good network. Most home accounts, you don't get 99.99% availability, and they don't guarantee it. They're not giving you what's called an SLA, a service level agreement. Most service level agreements, which are signed by businesses, by and between the internet provider and the business getting the service, have a clause in there which has an SLA percentage. It's either the 5 nines or 99.997, or maybe it's 7 nines. You pay more for more nines. But the 5 nines is kind of the industry standard for what we consider a secure, available network that does not appear to go down. Or maybe it goes down for 1 minute out of the day or 10 seconds out of the day, but you don't notice that. It's only down for 10 seconds, especially if it's down at 3 in the morning when nobody's using a network. Mean time between failure, MTBF, that's a term that we use typically to measure hard drive reliability. MTBF, mean time between failure. This is measured in hours. So a commercial grade hard disk drive, could be a hard disk drive or a solid state drive. MTBF common values might be 2 million hours. 2 million hour duty cycle. That means that drive theoretically could last for 2 million hours. Now that's many, many years. No drives last for that long, but a consumer grade drive, same size, 2 terabyte, 10 terabyte, might only have a mean time between failure rating, and these are usually published right on the top of the hard drives, of 40,000 hours. That equates to only about 3 years. Not very long. The cost difference is 2 to 3 times to 4 times more for a hard drive with an MTBF of 2 million hours, which, by the way, these are a lot of times very made up or statistically derived numbers. We haven't had 2 million hours worth of hard drives yet. How many millions of hours are in it? That's like 50 years. That's a lot of years. That's 100 years. We haven't had hard drives that long. Here's some other terms. So SLA, MTBF, mean time to diagnose plus mean time to respond plus mean time to fix equals the total mean time to repair a problem. Many times mean time to diagnose is pretty quick. Oh, I cut a cable. Well, okay, here's the diagnosis is you cut a cable. Mean time to respond and fix that might take a few hours, might take a few days, depending on several things. How many customers it affects. What is the criticality of that network? Is it a very important network that needs to be up all the time? So make sure you go look for it in the book and in the notes, and you can go Google for these, what each one of these terms mean. I'm not going to spend a lot of time on them. I want to try to get through this chart today, or this PowerPoint today. So performance management, this is a chart that you might see generated from MRTG. And what we're looking at, and again, usually we're using automated tools to look for our peaks and our valleys. Peaks are bad, valleys are bad. Not necessarily for throughput, although valleys can be bad for throughput because that could indicate, hey, there's a lot fewer people using our system than we're paying for. Maybe we need to adjust that. We want our trend lines in our charts to basically be right in the middle somewhere of our total bandwidth. We don't want them way up here all the time. We don't want them way down here all the time. Down here means we're paying too much money for it. Up here means we're using it too much. We got a problem with it. 0 means it's down if it's at 0. Excuse me. End user support with those help desks. This is solving the problems the users encounter while using network. Major sources of problems with user equipment. The first most common issue is hardware issues. That's because end users are actually a lot harder on hardware than data on servers. There's not a lot of moving parts in servers. There's a lot more moving parts with a workstation. You got the mouse, you got the keyboard, you've got the users move. If it's a laptop, you're moving stuff around all the time. You can drop the laptop. Servers, nobody's touching most of the time. There is no mouse or keyboard or monitor. Servers have redundant devices in them. They have commercial devices which are designed to last millions of hours. So hardware failure is very common. Generally the easiest to fix. Why is it the easiest to fix? Because one, it's either not our hardware, because you're using your own hardware, you're using your own laptop to access our network, or it's cheap. We have a dozen more laptops on the shelf. Let me just grab one and give it to you, because we're all using thin clients. There's no special programs on your laptop or your cell phone. It's all in the cloud now. That's how we put things in the cloud. We want thin clients. Or there's so many of these devices that you can just get up from your desk if the device on your desk fails and go walk to the cubicle next door that's empty because of COVID-19. Wipe the keyboard off and use that one. Again, because of thin clients, there's nothing on your workstations anymore. All the data lives in the cloud. All the apps live in the cloud. Lack of user knowledge or proper operation. The user didn't know how to use something, or they are using it inappropriately. They're watching Netflix, for example, when they're not supposed to. That's usually easy to fix. That can be done with training or reprimand or penalty or whatever it is. We can re-educate that user on the proper operation. Problems with software settings, or incompatibility, those are generally the hardest to fix, particularly software incompatibility. Getting a client program to talk to a server program, which are written by two different companies, and they're trying to use a common protocol like HTML, for example, or HTTP, I should say. Also, if there are servers in the middle that are trying to create a nice, pretty web page out of a database system, sometimes we can't tell where the breakdown occurs. Maybe it occurred at the database server, maybe it occurred at the web server, maybe it occurred at the client computer. Those are hard to fix because the problem is transient. Training is an ongoing responsibility of the network manager, not just for your end users, but you as a network manager. You must stay up to date on everything, on network trends, on the latest viruses that have been created, on the latest best practices that are now being followed. Things that we used to do 10 years ago, like RAID 5, for example, we don't do RAID 5 anymore, we do RAID 10. You can go look those, you can go Google those things and see what the difference is. We do things differently. We no longer manage our own data centers. We now put everything in the cloud. We now no longer give desktop computers to employees. We give them laptops. There's a lot of things we do differently because we find that we're trying to mitigate the most common problems that occur. And a lot of the most common problems that occur can be done by employing new methodologies, new techniques, new, better hardware. Cost management. We're almost there. We're almost at the end of the chapter. Total cost of ownership, or TCO. This is a measure of the direct and indirect cost to operate a device. So the direct cost would be things like the electricity, the cost of the software, the cost of the employee that's using the workstation. But the indirect cost would be things like the staff required to man the help desk and the network operations center and the insurance policy that we had to purchase to protect that computer from loss or theft. TCO of a Windows workstation can be as much as $5,000 to $10,000 per year. That's expensive. Why is it so much? Workstation computers don't cost $5,000 to $10,000, and they certainly last more than just a year. That's because there are many, many elements to making up the total cost of ownership. Here's what makes up the total cost of ownership. We have the application software, 8% of our budget. Network devices, our switches, routers, gateways, cabling, 9% of our budget. The client computers, 9% of our budget. The server computers, 5% of our budget. End user support and systems management, 31 and 38% of our budget, respectively. That's almost 70% of our total budget per year to maintain a set of tools for one employee to use to do his job. Why so much? And what do these two pieces of the pie represent? These are people. Systems management, that's my salary as a network manager. That's the contracts I had to sign with providers, with outsourced providers to repair things. End user support, this is the money I have to pay to my help desk people. This is the training I have to provide to my employees constantly to teach them how not to do stupid crap like give away their sensitive information to scammers. 70%, almost 70% of the budget is that. Therefore, what does that tell you in terms of cutting cost? What should you pay the most attention to when cutting cost? You should pay attention to those elements that involve people. People, I can't say this enough times, people are the most expensive element in a network. People equals dollar signs. That's because our computers are cheap. Automation is cheap. It costs a little bit more in the beginning. Managed devices cost more in the beginning, but it's typically a set price. And that automation operates on your network without regard to who it's operating with. Computer programs are not prejudiced. They don't get tired. They don't have boyfriends and girlfriends. They don't need sleep. They don't need vacation. They do the same job over and over and over again, and they do it precisely mathematically how they're designed to do it. So the goal, the major goals for saving money is whatever we can replace people with, or wherever we can replace people. Automate as much as you can. That's what our grocery stores have tried to do, right? With our automated checkout tellers, our ATM machines at the banks. You guys shop at Kroger with the automated checkout, or Walmart now. Why are they getting rid of checkers and getting rid of people? Because people are expensive and people are fallible. They found out, or they find that a lot of the loss and theft, the shrinkage of inventory, is because friends of employees of checkers pick up stuff off the shelf, and they go to check out and they're buying 10 of something, and the checker only charges them for 5 of something. They're in cahoots with each other. Or the checkers are just dumb and didn't notice, oh, he's buying 10, not 5. People are fallible. If you were checking your own stuff out, first of all, it's a more automated unit. Also, the responsibility is up to you. If you mess up, that's your fault. Usually the error at grocery stores is almost always in the grocery store's favor. Rarely is an error in your favor at a grocery store. So automate is one thing we can do. What's another thing we can do? Cut down on people. If you can't automate certain things and you have to have people as a necessary evil for training, for example, what can you do? How about reduce the number of people that you need to do that job through things like standardization? Develop standards for hardware and software configuration. In other words, rather than having 5 different desktop platforms for you users to use, some users are using a laptop, some are using an Apple, some are using a Windows machine, some are using Windows 7 machine, some are using Linux. Standardize, force all of your employees, or encourage all of your employees to use the same platform across the board, so that you can only hire one Windows expert or one Linux expert or one Apple expert. You don't have to have one of each. You don't have to have 3 experts on staff. Standardize. Also, standardization really helps, because if it is standardized and you do have to use somebody else's workstation, it's guaranteed that your workstation is going to work just like theirs, because it's the same thing. How many times have you ever sat down to somebody else's computer, maybe at work, maybe at home, and instead of a mouse, they have a trackball, and instead of a regular keyboard, they have those funky, ergonomically designed weird keyboards? Or they're left-handed and their mouse is on the other side, or they've set up their screen in a different way such that you can't find any icons to use. We strongly discourage that. We strongly encourage employees, or at least workstations that employees use, to be a standard unit. We don't do that so that we can save money buying 1,000 of the same laptop at one time, although there is that cost saving, but that's not usually why we do it. We don't do it to get a quantity discount. We do it because if everybody's driving the same car and we have a problem which is occurring, everybody knows about that problem, or it's a well-known problem, and it's an easy problem to fix, an easy problem to mitigate, or an easy training to do. Well, if you're getting bad gas mileage, don't go as fast, things like that. We can reduce the cost of installing new software and hardware by working with vendors to try to recontract our support contracts, for example. I do that sometimes. Centralization, that's the other thing that we can do to cut costs. Centralize our help desk. At U of H, we used to have separate help desks per building, per department. We had like a tech guy in every building. Nowadays, we don't do that. When you have a tech issue, you call a centralized help desk. Although we still have help desk people in College of Business because we're teaching stuff and we do have some unique systems that are different. But for the most part, if it's I forgot my password issue or I need access to the internet issue, you're dealing with a centralized help desk, which is in the building, in the College of Computing building. Also, we're moving to thin client architecture and cloud-based architecture so that the responsibility of the care and feeding of servers and databases and backups and maintaining electrical battery backups and air conditioning systems, that's not our responsibility. That's the responsibility of experts in that field who are doing it for 1,000 other people. Again, getting back towards that standardization. Let experts deal with that, outsource a lot of that, so that if you do have a problem on your laptop or your desktop computer, there's no data on your computer. There's not even applications on your computer. They all live in the cloud. All you got to do is go to Office Depot, buy another laptop, or Micro Center and get another laptop, or go to the phone store and get another phone, and you're back in business. It's okay if you lost this thing because there's nothing in here, or there's copies of everything in here out in the cloud. Cutting costs. The goal to cutting costs is to cut people. That's the answer to that. So implications for this chapter: network management requires technical understanding and management skills. That's why you learn as an MIS manager the tech stuff I try to teach you, which is just a scraping of the surface, literally. I'm not teaching you guys a lot of heavy tech, although I'm considered very technical. I don't teach a lot of heavy tech because we don't have time for it. That's a 4-year degree in technology. But that's why you're also taking accounting classes and statistics classes, and that's why you're a business major, so that you can live in the middle. MIS majors are great because we live, and MIS people are good. We live in the middle. We know just enough to be technically dangerous and look good to our students and our girlfriends because we sound like we know what we're doing when we're repairing a laptop or whatever, or troubleshooting a problem. And we also get to hang out with the bosses of the company and go spend the weekend on the company boat because we're one of the managers, we're one of the high paid people in a business. MIS managers coming out of U of H on the average are being offered 50, 60, 70,000 a year or more with little to no experience. IT people aren't being offered that kind of money. And that's because a lot of that's being outsourced to India or Indonesia or somewhere else. Network management is increasing in complexity, but it is getting easier because we have a lot of good standardized tools now. Qualified personnel, that's the bottom line here. People cost more than hardware. We cost more because we demand more and we are fallible. Okay, that's it. End of the class. You can go take the test now if you want. No, it's actually not ready to take yet. I need to change a couple things. I want you to concentrate right now on getting your draw.io assignment done. And again, like I said, if you have to, I'd rather that you not. But if you just have no idea what you're supposed to be drawing based on my description, draw this figure 12.7 in draw.io or use it as a template. Then submit that on Blackboard. Try not to email me. Submit it on Blackboard as a shared document. Go share it with me, profjake@gmail.com. That's in the Blackboard assignment, profjake@gmail.com. And then I will go manipulate that draw.io file. Don't just print out a PDF of it. Give me a draw.io file. You can do the Wireshark assignment if you want. I'll grade it if I get time to grade them. They'll be considered extra credit. And I do recommend that you do continue to play around with these tools, like the code, the programs that I suggested you download. Wireshark, the Wi-Fi analyzer app that you can run on Androids, the advanced IP scanner and advanced port scanner. These scanner tools are very useful in helping to understand what's going on in networks and network management. Make sure that if you're missing a grade for any of the things like the network game or the cable that you did, let me know. I'm still working on exam 2 grades. I'll try to get those done. Yes, you can draw home network map. Just make sure, in terms of complexity, as an example, like I said, I'm looking for this layer of complexity or more. So a home network may not be that complex. I need to see at least 15 endpoints, 15 elements. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's like 17 elements right there.
Excuse me, Professor.
Yes.
So just to clarify, so, we can make our own network for that assignment?
Of course, you can make one up. Doesn't have to be this. These are all just conceptual drawings.
I was just confused because on the Blackboard it says that there was a specific instructions how to do the assignment. So we
that is correct, and and you can still do that. And that is because we used to have physical access to the EI lab. So I wrote the description down with the thought that, okay, if you guys don't exactly know what's going on, you can go to the EI lab and look at the cabinets, and you can look above and you can see the wiring above, and you can see all the workstations, and you can physically figure out how to draw a map and start from there. But since we haven't been back to school in 2 months, some of you never went to the EI lab, or you went one time and you don't remember what it was.
Right.
So you don't have to follow that.
Okay.
I'd like you to follow that if you could, but you don't have to.
What about the extra credit draw.io?
The extra credit draw.io, if you choose to just draw this diagram here, I'll want you to submit a copy of this same draw.io file, name it something different, and add additional elements to it.
Okay.
When you watch that tutorial, there are other things you can do in draw.io, such as you can make these elements have hyperlink text in them. So you can click on it and it'll go open a web page. It can be a fake web page. You don't have to, or you can go to the manufacturer's web page site. If you called something a Cisco router and you click on it, it'll go to Cisco and pull up the manual or the management guide for that specific Cisco 5505 router, for example.
Okay.
In other words, watch those tutorials. There was a tutorial video. The first
I have
one was very simple. The second one was more complex. If you watch that video, and he introduces to you additional elements which are very useful in draw.io in terms of network management. Can we submit the same draw.io assignment? Yes, that's what I'm getting at. Submit the same thing, but with extra significant details. I need to see a significant difference. Make them 3D if you want. Add another scope to it. In other words, you might add a LAN scope to this backbone network. This is obviously a backbone scope here. You might extend this out and over here draw out one of these LANs on the 4th floor and show its connecting relationship to this switch right there. Okay? Or make it 3D. There's a lot of cool 3D effects that you can do with draw.io, which again, the goal of draw.io, the goal of these network mapping programs is to make your job as a network manager easier to identify and locate physical layer issues and problems, and allow you to physically manage things easier by starting at the physical layer. Everything starts at the physical layer. Okay? Any other questions?
I have a couple more questions for you,
Okay.
Professor. The first question is, since the Wireshark one is an extra credit, right?
Yeah.
I was just going through the syllabus. So how will the grade distribution will be done? Because it was 20% of the grade.
Right, it was 20%. I'm going to basically try to redistribute the tests evenly and the assignments evenly so that Wireshark essentially goes away. So
And
if the tests were 20%, they'll probably be like 22.5%. Or I'll add a little bit more to each thing so that Wireshark goes away and so that the draw.io assignment, which originally was a total extra credit assignment, the first one is mandatory.
right,
And if you need additional extra credit because you missed the network game, for example,
right.
email me. But it's going to involve something like installing DDWRT on a home router, which a lot of you can't do because you don't have those resources.
Okay.
DDWRT, or installing VirtualBox and experimenting around with Linux and Sophos or Firewall software.
Okay. Okay. So right now the Wireshark one will be an extra credit for how many points?
5 points.
5 points. Okay. And one last question for you.
Mhm.
So the grades on Blackboard right now, like the percentage grade, is it correct or is it
Oh
not?
no, I'm sure it's not correct. Because right now it's showing like a 99% off for a lot of people where I haven't even graded exam 2 yet.
Okay. There
So
will be a curve
don't
on.
rely on that as going, oh, I can blow off the test because I got a 99.5, even with the 75 on exam 2. That's not accurate. And that's because I haven't fully graded all of exam 2. I haven't applied any curves. The calculation, the percentage calculation is not taking into consideration exam 3, which has a higher weighted percentage, even though it is an easier exam. Exam 3 will be easier. It's just 40 multiple guess questions, but
Okay.
I weigh it higher because I figure if you made it all the way through the class to the end of the class, then that's how I'm giving you a little bit of credit as well.
Okay. Thank you.
Any other
There will be a
questions?
curve, right, for the exam too?
Exam 2, yeah, almost definitely. There'll be a curve. I don't
Okay.
know about exam 3.
Okay.
There are assignments on Blackboard you didn't do. Like, if there's any I didn't talk to you, if there are assignments you didn't do that you were supposed to do that I talked about, you need to do them. If I never mentioned them, yeah, like that lab tour and VM number, don't worry about those. Okay, I'll just give everybody credit for those. All right.
Right. I think
Thank you
that's
for
all. Thank you, Professor.
participating. I'm glad we got through this with COVID-19. I'll be teaching in the summer semester, 4397. It's going to be all online. So the same thing that we're doing now, we're going to do it all online. Everybody be safe. If you have any questions before you start exam 3, which by the way, I'll make available probably tomorrow by noon, make it available through either Saturday at midnight or Sunday at midnight. You have some time to do the extra credit because our official last day of the semester is not for about another week and a half, 2 weeks, because of final exam schedule. But we don't really follow the final exam schedule in College of Business. We try to get our grades in as soon as we can for you guys, especially for those of you that are graduating. So see y'all later.
Later. Thank you.
Thank you. Thanks for taking my class. Tell all your friends.
Yeah, definitely. Have a good one, Professor.
You too.
All right. I'm out.